This was our RC 2014 Classic 2 at the end of the last video. Today we're going to add another module to the system, a 7-segment display. As you will see, this board has a total of 4 7-segment units at the top of the board, plus a selection of resistors, capacitors and no less than 7 chips. This new module we need to make a slight amendment to the backplane, adding jumpers between slot 2 and 3 to allow modules in both slot 1 and 2 full access to the backplane. The kit arrives well packaged, and a remarkably good assembly guide is available in PDF format to download. This illustrates each component, which will greatly aid those doing this for the first time. There are quite a lot of resistors to solder into this board, so take your time, and as always start with the lowest profile components first. Resistors and capacitors, followed by the IC sockets, and finally the 7-segment displays. Now comes the moment of truth when we're going to power up our RC24 Classic, hit the reset button, and we're going to attempt to program in BASIC this new 7-segment display card. So now we're in BASIC. So what we need is a BASIC program to actually change the value on each of these 7-segment displays. In the PDF document, which you can download, which covers the assembly of the module, there's a section entitled How Do I Use It?, telling you the settings for the jumpers and the settings for the addresses. In this case, the decimal address 56 is the right-hand digit, 57 is the next to the left, 58 is the next, and 59 is the left-hand digit. You can also set the decimal points individually. So if we wish to send the number 8 to the right-hand digit, we would use the out command followed by 56,8. If we wish to blank the digit to turn it off, we can then send the value 10. So if we go into BASIC, and we will start a BASIC program. This is a small program in which there are going to be 2 subroutines. We want to reset the display first of all, and then what we're going to do is step through a for next loop from 1 to 9. Then we're going to output to the right hand segment display the value of the variable R. And then we'll simulate a wait by calling a second subroutine, and then we'll go on to the next value of R. So let's put in both of our subroutines. This is a subroutine to reset our display by stepping through each of the segments in turn and sending the value 10 to them. And we've also added our subroutine that performs a wait, merely by counting from 1 to 1500. Now that our initial program is set up, we can attempt to run it. And there we have our display displaying the values of 1 till 9. We can put in a slightly more advanced piece of code to use all our digits. We will clear out the existing program and put our new one in. And if we attempt to run that, this will step through the numbers as before, but once it reaches 9, it will go on to 10 and above. So what we've achieved today is we have successfully added our 4-digit 7-segment LED display module. This can be used as a counter for any application we have that requires such a device. Perhaps you could find a use for such a module in your own systems. In our next video, we're going to look at replacement for the RAM module. The RAM module at the moment is dynamic RAM. Whenever the power is removed, the memory is wiped. The next video will cover the addition of a non-volatile RAM. But that's it for today. Thank you for watching.